people, and welcome. In this video, we're talking about exponential values. So how to evaluate things with exponents. Now, this is an introductory video, so we're not going to go into the exponential properties. We're simply going to be evaluating expressions with exponents. All right, now what does an exponent tell us? So when you see something with an exponent, for example, let's do something basic. Let's do a to the n power. There are a few things that the exponent tells us. The first thing is that there is a secret bubble around a. Now, mathematicians, if you're in my class, you already know this. Mathematicians are lazy, so we don't typically like to write that a in a bubble or that number in a bubble, but that bubble does exist. And what that tells us is that this right here is called the base. And the exponent, what does the exponent tell us? The exponent tells us how many times the a is being multiplied by itself. Now, I underline the word times because times is kind of like a hint of what you're supposed to do. So how many times you're going to write that base, meaning you're going to be multiplying it that many times. Now, be careful of things with negative. So if you have a negative a versus a negative on the outside. Now, a lot of times you're not going to see a bubble, okay? This is what you're going to see. This one, you actually would see the negative a inside the bubble, but this, you actually don't see a negative. You actually just see the letter a, or in this case, numbers, since we're going to be evaluating numbers. So anytime you see a negative out in front, that doesn't mean that negative is inside a bubble. That means there's a secret bubble around our number, or in this case, our variable, and that is not part of your base. So this negative is part of the base. This negative is not part of the base. Okay, so let's do some examples on writing these out and what it means to be an exponent. So example number 1. So let's do something like this. Let's start out with 6 times 6. The base is what we are multiplying. So what are we multiplying? And we are multiplying 6 by 6. Now, the number has to be the same. For exponents, it's because we're taking that base and multiplying it however many times by itself, the base has to be the same. It's the same base. So since 6 and 6, we're multiplying 6. How many times? And this time I actually wrote, how many bases do you have? I have 2 bases. So that means your base is 6. Your exponent is 2. So what are we multiplying? 6. How many bases do you have? I have 1, 2 bases, so that means my exponent is 2. Let's do another example. Let's do something like negative 7 to the 5th power. Again, what's my base? My base is what is attached to the exponent. So my base is negative 7. What is the exponent? The exponent is 5. what does that mean? That means you write the base 5 times. So what do we have? We have -7, that's 1, times -7, that's 2, times -7, that's 3, times -7, that's 4, times -7, that's 5. We're writing this 5 times. So if we were to evaluate this, we would evaluate this by multiplying -7 by -7 by -7 by -7. It's going to give us a very, very large number. All right, let's move on to more examples. Lots more examples. So let's go ahead and do one. Since I did the -7 inside a bubble, let's do one that is not inside a bubble. And let's do, this is example 3. Let's do a fraction. 5/7 cubed with a minus on the front. So this is a little bit different. So what's our base? Our base is what is attached to the exponent. And attached to the exponent is 5/7. What is the exponent? The exponent is 3. So what does this look like? Well, how many times am I writing my base? I am writing my base 3 times. So that means I have 5/7 times 5/7 times 5/7. Now here's the thing though. We still have this negative out in front. This negative out in front just means that all of this gets multiplied by a negative at the end. So whenever we get our answer, we just then multiply by -1. Let's also go ahead and evaluate some of these and to solve them out, what they are. So let's do 2 to the 4th power. Let's figure out what that is. My base is 2. My exponent is 4. So that means I am writing this 4 times. So 2 times 2 times 2 times 2. So how would I evaluate that without using a calculator? You have 2 times 2 times 2 times 2. So what you're going to do is you're going to like pair them. Do 2 at a time, no pun intended, because we're working with the number 2. But we're going to do 2 at a time. So I'm going to multiply these first. So I'm going to say 2 times 2 is 4. 2 times 2 is 4. Now I still have a multiplication in between them. So now I'm going to do it again. 4 times 4 is 16. So my answer for 2 to the 4th power is 16. Let's do another one. Example 5. Here we have -3 squared. Again, be careful. Anytime you see a negative out in front, that means it is not part of the base unless it is in a bubble. So this is what we have. Actually, we have a negative, then we have 3 squared. So what do we have? We have a negative. Then how many times do we have our base? We have our base 3 times. So 3 times 3 is 9. I still have my negative. So my answer to -3 squared is a -9. And let's do one more. Alrighty. I'm trying to think of a really good example for you. Let's do this. 4 cubed. And what's my base? My base is 4. How many times am I writing it? 2 times. Just kidding. 3 times. My exponent is 3. So I have 1, 2, 3. So how do I solve this? We're going to do 2 at a time. 4 times 4 is 16. I have this times 4 left over, so I'm going to bring it down with my multiplication symbol. 16 times 4, that is what? 64. So the answer to 4 cubed is, that should be an equal sign, 64. All right, beautiful people, this is the shortest video on how to evaluate expressions with exponents. Very basic stuff. I wanted you to just have an idea before we move on to a little bit more complicated stuff. All right, that is it for this video. If you caught a mistake, please let me know where it is. I am human. I would like to learn. Enjoy the rest of your day. Bye.